actually. I mean,
okay, you actually, okay, I just start from here only. Computer rights and blocks I told, right? This one. I remember, right? This block. So there are the in Hadoop 2.x, the block size is 128 MB. And Hadoop 1.x, the block size was 64 MB. So,
that's what to say, I think, yeah.
Huh? This one. Actually, I was talking about like if the file size is 256, so how it will be distributed in how many blocks, right? So default block size in Hadoop 2.0, that is 128 MB, and Hadoop 1.x is given the 64 MB. So one thing is like what is the reason behind they have given this larger block? So why they kept it 64 MB block size block size in Hadoop 1.x, and they made it large 128 MB default block size. It can be changed, but this is a default block size Hadoop 2.x. Okay, so basically in Hadoop, what we are going to do, we are reading the large file, right? We are reading the large file, correct? Files are GBs and TBs, right? Terabyte. Okay, so GBs, terabyte, GB, TB, and petabyte. Okay, so in Windows and Linux, the block size is very less. Okay, the block size is 6 KB. So if I say when we are reading any file in the Windows and it is like a notepad file, it is a 100 MB file. So you know, right, it takes time to load the file if the data is very large, okay, in Windows, because what is the reason there? 6 KB is very small block size. So if the block size is small, the number of blocks will be more, right, if the file size is more. So Hadoop, those who designed the Hadoop framework, right, Hadoop framework people, they thought like they will be giving larger block size. They will be giving large block size, because the number of blocks will be less. And because of that, it will take less time. To read a file. So this is the one question generally they ask, like, why they decided 64 and 128 MB, because the larger block size will be there. So in Hadoop 2.x, they made it more larger. Okay, suppose I am going to read a 1 GB file. So 1 GB file with 128 MB block size, so hardly 7-8 blocks will be there. Okay, so that will be very less block size. Okay, so number of blocks will be less and the data will be read faster. That's the reason to design the block size is more. Okay, so here we see like 256 is 128 MB, it's completely, but suppose the block size is like file size is 300 MB. So in this scenario, what it will do, 128 and remaining 44 will be given to block C, but another file will be reading this block also, because the block size will be utilized. Okay, if remaining block size is there, so it will be utilized by some other file. But who is keeping this all information? So I told you the metadata is there, right? So metadata is stored in the name node. So name node is having metadata as metadata. This is keeping information about data, actual data in data node. Okay, so that is the reason name node memory with high. Memory configuration, hardware configuration will be very high. Okay, so what is the computer racks? Like basically we are dividing the data into physical machines, and these physical machines are placed in rack. Okay, so if I say how the blocks copy will be replicated. Okay, so we are saying the default replication factor is 3, but we can change this replication factor to 1, 5, it depends on the criticalness of the file. If the file is highly critical, then the block size will be increased to more. But if file is less critical, then block size will be less. So basically, these racks you can think of data center. So you have seen the pictures of the data centers. They are very, very big racks are there. And these racks are having a node. Okay. So if I say this is a one node, this is a second node, this is a third node, fourth node, like these are the machines. Okay. And so what is the rack awareness means? Basically, what is the plan? What is the script is written in Hadoop, how the block will be replicated. Suppose I am writing the data into the data node. So how name node will decide which data will be going to which node. So basically it will be finding out the particular node. So suppose this green copy means this is a one copy here and two more copy will be here. If red copy is there, it will not coming a complete picture. If two red copy is there, so one red copy will be here. So what is the policy? If one node is having one block, so another rack is having two different nodes, having the adjacent node having the two copies, one by one. Okay. So like this, the data is distributed. Okay. If the blocks are like, suppose if I say the replication factor is 5, so one copy will be here, two copy will be here, and two copy will be here, like this. So this will be green, these two will be green, and these two will be green. So like this data will be distributed. Okay. So the main idea of this rack awareness is like one.
No.
Yeah.
Actually, I'm a little bit confused with the rack awareness.
Yeah. What is the question?
Yeah, I'm not understanding what is the blocks, how they divided into that.
Okay. First you understand like the data is divided into the block. This is a fundamental unit. Right? Suppose if I say I have a 250 MB data, I understand like if this is a file, so file size will be the MB, right?
Okay.
In terms of the size, if I talk about, we understand MB, right? We don't understand the block. Block is in terms of Hadoop. Okay. Basically, what Hadoop has done, Hadoop knows like if the size is 128 MB, it will become one block. Like the block means
if it is more than that, it divides into another part.
It will go automatically to another block. And now
128 again.
These two blocks you divided, this Hadoop has divided data in two blocks, but where these blocks will be placed, right? Because if suppose this is a different data, right? This 128 MB is a different data, this is 122 MB is a different data, right? So this 128 MB will be one block at one node. Another two copies of this 128 MB will be on two different machines in the same rack. That is this concept. Okay, so rack means rack, you understand, right? Data centers have racks, right? Rack means like your wardrobe. Like we have the what we can say, one drawer. Different drawer are there, right? Like that. So rack means we say rack 1, rack 2. So rack means like complete set of nodes. That is the rack 1. Rack 2 means where the other some number of nodes are there. Rack 3, some other number of nodes are there. And here is like now switch are there, right? You know, right? Network terminologies, right? Like there is a something like the data transmission, right? So if that transmission will be got lost, so complete rack will not be connected, correct? Right? So basically, how the data will be distributed, that is called rack awareness policy. So here are the three different policies. Like one policy is all the blocks, same data block, you keep it in one rack. One node, second node, and third node. So this policy is good or bad? What do you say? Suppose I keep in rack 1, one node, one block A, block B in second node, and third node, block C. And they are the same copy of the block. Like same.
Okay.
So is it good or bad? If rack is down, suppose if I say this rack is down, so entire data I will be not getting, right? Even suppose one node is down, the second node will also be down, third will be also down because I am not able to access this rack. Correct?
Yes.
So what I will be having another plan is, I just said another policy is, I keep it one block in one node here in rack 1, and other two blocks of the same data, I keep it in rack 2, two adjacent node. So suppose this rack is down, so this data I am not able to access, but other two
You
nodes,
can access.
right? But here one question comes, like this rack also can be down also, right? So in that scenario, first this rack is down and this rack also down. So I will increase the application factor. I will create another rack 4 and two more copies I will create. So I think that will not come. Rack 1 is also down, rack 3 also down, and rack 4 also down. Correct. So it is not necessary that all the racks will be down at the same time. Correct.
Yes.
So what the policy they say, because while they are keeping it on adjacent node, they can keep it one here and one here in the rack 2 and one rack 3. Because data access is much faster when in the same rack is there. Because we have connection in this rack, right, for all the nodes. Correct?
Yes.
So if I'm going to access this rack to this node and it is down, suppose this node is down, so immediately I can access from this node. Okay. So this policy is better because here is one block copy in one rack in one node, and two other copies will be in two different another rack on adjacent node. This is adjacent node, same like adjacent node. Adjacent means the node is one after one. That is adjacent node. Okay. Theoretically, I will share the document. Okay, that will be more clear. I am just talking about like scenario, like how in real time it happens, right? Okay. So when you go through the actual theory part, right? What is the rack awareness and why it is important? It is important in terms of faster get, like we can get the data faster. That is our main idea behind this rack awareness policy. Because the data is also important like writing the data. Correct? So reading the data, while I'm reading the data, I should know which node are available and which block is alive. I should know all these information. Okay?
Okay.
And I talk about, okay. So what is this is the architecture of Hadoop distributed file system. So Hadoop distributed file system basically made of three components. One is name node, data node, and backup node. Backup node is called secondary name node. Okay. So we are talking.
Backup node is called? What is backup node is called?
Secondary name node. Secondary name node. So two name node we seen right in Hadoop 1.x. One is name node and secondary name node. Okay. So secondary name node is kind of backup copy. So why keeping it secondary name node? Because we are not rely on the master name node. Okay. So suppose it is down means entire cluster will be down because all the metadata information of these all data nodes here in this name node. Right. So even the data nodes are alive. This name node is down means entire cluster is down. I can't access. Okay. So what I kept, I just making it synchronization between this name node and backup node, secondary name node. So whatever data is present over here, that should sync to the secondary name node. So any point of time, like my name node is failure. Suppose I'm a client here. I'm a client here and I'm going to give the request to the name node. But this name node is down. But my Hadoop framework knows who is the backup of this name node. Secondary name node, it will point to the secondary name node. The secondary name node will be treating as the name node. That is the idea. Okay. Now, how this name node is communicating with each data node? There is a heartbeat mechanism is there. So heartbeat mechanism is like every name node is sending some signal to each data node. Because all the data nodes IPs are where? This name node. This name node knows all the IPs of the data node. So whenever I am creating a cluster, while creating a cluster, I will be providing all data nodes IP at the name node. Okay, because it is a master. So when any point of time any data node is down, so this will not give any heartbeat acknowledgement. Okay. sending every 10th second, 30 second or 10th second, it will be sending one heartbeat. So whichever data node is not replying back. Suppose if I'm alive, then I will definitely return back my signal, right? If I'm not alive, I will not send any signal, right? So what name node will come to know this data node is down. So whenever the client is going to access this data node, it will find another backup of this data node because these are the replica. So if I say this is the one side loop block, these two replicas are here. This green block, two replicas are here and here. Okay. So name node has all the information. If client is requesting this particular data node, this block, if it's down, it will redirect to this one. Okay, to read the data. Okay, so what is the purpose of the heartbeat? The heartbeat purpose is to make a sync between name node and data node. Okay, so every 10 second name node is sending the signal to the data node and data node sends the signal to the name node. Okay, another thing is balancing. Okay, what is the balancing thing? So whenever any client is saying I want to write a data on some data node, so what name node does, it will find which data node is free, like block of the size. It will check like what is which data node is free. So it will allocate the data node over there. But sometimes now what situation comes, it is randomly giving the data on the data node, so it is undistribution of the data node block on the data node. So this data node is having more number of blocks and this data node is having the less number of blocks. So because of that, name node we have to run a command, balancing command, balancer. So one balancer command is there and this balancer command is balancing all the data node with the equal number of data node, equal number of blocks. But you know, right, once we are doing equal number of the blocks, in that scenario, we have to change the metadata. Correct? Otherwise, if the metadata is not changed, if it is the old metadata, then it will be looking for the different block at the different node. Correct? Got the point? Okay. So after running this balancer activity, there is a balancer command and this balancer command is a Hadoop admin command. So it takes half an hour time and after this balancer command, automatically all the data nodes, metadata will automatically sync with name node. Okay. So this is called the balancing. Okay. So in Hadoop architecture, what happens? Either we are reading the data or writing the data. Only two activities we do. So when we are writing the data, so name node is communicating to all the data nodes. When we are reading the data, in that scenario also, name node is communicating to all the data nodes and it is giving those IPs to the client here. So client will directly interact with the data node to read the data. Okay. But initial, who is the point of contact to the data node? Name node only. Okay. And the next thing is replication. So replication is already maintained, right? So if we are having replication factor 3, so automatically 3 copies will be created. Suppose I have set the replication factor 5. I am not talking about the command line. Actually, replication factor, there are two ways we can set. One is replication factor using command, that is setrep. And this replication factor command is only particular file or directory. It is not for the whole system, not for the whole SDFS. But when I'm just installing the Hadoop, and there is we have to set some configuration file. So there is one file, SDFS site XML, SDFS-site.xml. So this file is related to SDFS property. If I have set replication factor, if I set here in this XML file, I set replication factor by default 3. If I set 1, set to 1, so all the one copy will remain there. So one copy is no replication factor, right? One copy is a default copy, right? But if I'm setting the replication factor 2, then it will be creating 2 block copy, right? Every block having 2 copy. Okay. If I give the replication factor 3, this is the default one. If I set 4, so 4 copies of the block. So this one is applied to the whole Hadoop distributed file system. So every file, every directory will be following this one. But whenever I'm just setting through the command, so this one is overridden. Okay. So this command is having the higher preference than the SDFS site.xml. Okay. So replication factor will be set like using the Hadoop site.xml. Okay. This is clear, this architecture. Like what is the purpose of the name node, what is the purpose of the backup node, like secondary name node, what is the replication factor.
That's clear, yeah. I mean,
it's a theoretical, nothing practical, nothing is there, just a conceptual way. Right? It's a it's like a concept, right? Just like how read and write happens. Okay. So somebody has to describe the SDFS architecture in terms of read and write in SDFS. So you have to tell about, so whenever read happens, so what process is happening and what write is happening, so what name node does. So basically name node is a master and it is a single point of contact. So name node will decide like what it has to do. If it is doing read or write, so it will accordingly it will work. Right. So these are some theoretical terms like what is a master slave architecture, data node is storing the data, file is split into number of blocks, and these are stored on the data node. Data nodes are read or write equal perform block creation, deletion, replication, upon instruction from the name node. Okay. So read and write is a main operation, but other than read and write, like block creation also. So name node will be instructing to the data node, create this block. Okay. And whenever somebody is asking to delete a file, so whatever block is there in the SDFS, those will be deleted. But who will be deleted? Data node will be deleted, but who will be giving instruction? Name node will be giving instruction. Okay. So either block creation, block deletion, or block replication. 3 things are there. So block creation will happen when we are doing write operation. Block deletion will happen like when we are having any delete request. Like suppose the client is saying delete my file. Okay. So and replication will occur when writing is happening. That moment replication will happen. Right? So suppose one block is written in one node, extra 2 more blocks will be written in the 2 different nodes. That is replication. That is replication. Okay. So I think this slide I told local mode, distributed side, pseudo distributed mode, and fully distributed mode. Local mode means like when we are working in the same JVM, that is local mode. Like you are working on your Ubuntu virtual box, right? Hadoop environment. That is local mode. Because
okay.
Machine and all the services are in single JVM. Okay. Pseudo distributed mode means machine is one, but VMs are separate. All services running in a single machine, but in different virtual box machine, virtual box VM. Okay. So you can get it coming because their IPs will be different, right? Once they are created in a separate JVM, a separate service, so it will be a separate kind of machines. But actual physical machine is one only. Physical machine is one like this. But what you did in VirtualBox, you created 4 machines, 4 VMs, and each VM you created one service. Like one machine is mail node service, one machine is data node service, one machine is like this job tracker, task tracker. Task tracker and data node will automatically come on one machine only. Okay, because that will be correlated, right? Because data node means data related and task manager or node manager is related to task on that particular data, right? And fully distributed mode, it is entirely different. It is like a production. So you can say machines are separate, JVM are separate, or services are separate. Everything is separate. So each machine having its own service and separate machine is there. So this is production cluster. Okay. I think this is clear. It's an easy one. And read and write, like I was already talking about read and write. Here you will understand what is a flow. First, client is asking for open a file. Then, like client is asking for open a file, and then this request is going to the main node, get the block locations. So once I get the block location, then client will start reading the data from the different data nodes. Okay, and finally once the data is read, then request will be closed. Okay, so this is high level architecture. Okay, this is architecture like how basically SDFS client, how it is reading a file from the different data nodes. So block location means IPs. Like this particular one block, it will get all the blocks. Which block is right on which data node. Okay, and write for me is, suppose I am going to write a file. First, I will give a request to the main node to find the data node where I can write my packet. Okay, so this is the first step. Second step is I got the data nodes and then I start writing the block by block. So first I am writing the first data node which I got it. If suppose some crash happened here, okay, suppose my data is not written on this data node, so name node will assign the another data node. Then it will come to this fourth step, then fifth step, then finally it will return back like this. And finally the acknowledgement is returned to the client. Okay. So writing data is a sequential process. It is sequential. But reading process is random process, right? Because multiple blocks information I got it. This data is on this node, this data is on this node. So that will be also sequential, but the data, the block size, the block number of blocks I will get it at the time of reading. I will get all the block information, get the block locations. So name node knows if for this particular file I am going to read how many blocks are there and these blocks where it is located. Okay. But these blocks will be read in the same sequence, right? Otherwise, it will not give the correct data, right?
Right.
And job tracker and task tracker, these are the critical terms like job tracker functionality, the resource management, managing the task tracker, and this one. And the task tracker is the simple function just performing the task on that particular data node. Okay. This one is covered. This is a different diagram, right? Track awareness. Okay. Okay, what I'm going to tell next thing is this ecosystem I told. This one. This is high level ecosystem. So what are the components in the Hadoop? So Scoop is for the structured data. The data can bring from the RDNS database. And the Flume is for the semi-structured and unstructured data. So data can be a log file data or server log files, or we can say the data is a PDF, JSON, XML. So those data we can bring into Hadoop using Flume. Okay. So basically import or export of the data into Hadoop file system, the two main tools are there. One is Scoop for structured data. For semi-structured or unstructured data, we have Flume. Okay. And analytics tool, we have Hive, Page, and MapReduce. These are three tools mainly for analytics. But nowadays we are using mostly on the Hive. We are using Hive, but we have MapReduce is written in Java. Page is written in like Pig Latin script is there, and Hive is a SQL data warehouse. Like simple, like we write a SQL queries. So whatever code we write in MapReduce, it is a 200 lines of code. At least that will be converted, we can say 4 lines of code in Pig and 1 line of code in Hive. So simple Hive, we write a SQL query. select star from table. Okay. So basically the core productivity, I will say the Hive is very low productivity is more in Hive. So the developer will take less time to write Hive script rather than like MapReduce and Pig. So Pig and MapReduce, they will take more time, but MapReduce is completely based on the Java. Okay, code in Java. Okay. Another component is UG is there, that is the workflow scheduler. So suppose I have to repeatedly I have to run the job. So how can I run it? So have you heard about quad scheduler? Quads in the some APIs are there, quads API. Have you heard about quads?
No.
Okay, so actually scheduler you know, I understand, right? Like scheduler means like something I want to do repeatedly. Okay, so how can I do it? So the UG is a one scheduler tool and it is designed the workflows. Okay, so I will show you one example to create a one job like Hive job, Scoop job, like how can be scheduled through UG. Okay, so the main advantage of UG is like scheduling the job. So my job can be run repeatedly. Okay. So suppose a Hive script I have, I can run manually Hive script, but that is only one time. But suppose I have to run the script number of times, multiple times. So I will use the UG workflow scheduler. Okay. And Mahout is a machine learning model. Nowadays nobody using machine learning in Hadoop. So now machine learning is directly used in Spark. So there is a Spark, one module is there, Spark ML. If you remember, I told about the Spark Core, Spark SQL, Spark Streaming. These are the modules: Spark Core, Spark SQL, Spark Streaming, Spark ML, and Spark Graph. These are the main modules. So Spark MLM is best suited for the machine learning package. So Mahout is a completely Java-based machine learning. Same like the MapReduce is a Java-based. Same Mahout is also the Java-based machine learning libraries in Hadoop. Okay. So better than Mahout, we use it in Spark. Okay. Using Spark MLM. This is all Hadoop commands already we see. So is it clear so far, Karthik?
It's clear, but again I need to go through the.
This one, okay. So mainly when we install the Hadoop, so we are having these configuration files. Okay. So one is env.sh. Actually, these files now we will not like come across, because if we have already installed, pre-installed, if you're manually installing Hadoop on Ubuntu, then you will come across with these files. Okay.
Okay.
Basically, Hadoop env.sh is having the environment. It's an environmental file like Java, Java home path. So that is defined in Hadoop env. Okay. Core side, SDFS side, and MapRed side. Okay. Core side is some common property which is related. You know, Hadoop is having the two components. One is SDFS, one is MapRed. Okay. MapRed and SDFS. Okay. So if I have some common property which is related to Hadoop and MapRed, I put it in this core side. Okay. If the properties are related only SDFS, I will keep it here SDFS side. I told you that replication factor, right? So replication factor is not a property of MapRed. MapReduce. It's a property of storage, right? So it will come in SDFS side.xml. And MapRed side.xml is like MapReduce job related property. I will keep it in MapRed side.xml. Okay. And why they have given yarn side.xml? Because Hadoop 1.x, this file not is there. Okay. Because I told you Hadoop 2.x is called yarn. Right? Yet another resource negotiator. Okay. So Hadoop 1.x, these file will be there, these file and these two, not this one. But Hadoop 2.x, they have given one more extra file, that is a yarn site.xml. So which is having the information related to yarn implementation. Like I told you, there is a standby name node concept is there, right? Like parallel name node. So when name node is down, so one parallel name node will be there. It will become active. Okay, active name node or passive name node. Okay, so more than one name node can be there. Hadoop 1.x, the configuration is only one single name node. Hadoop 2.x, suppose 100 nodes are there, so they will keep it at least 4 name node. If 1000 nodes of cluster is there, at least they will keep it 6 to 7 name node. What they will do, like 100 nodes, they will be one name node. Another 100 nodes, they will be another one name node. So like this, it will be more easy, right? Like suppose if I say one single name node, I am giving 1000 nodes. How much work will be there? How much workload will be there on one single node? That will be too much, right? Correct.
Yes.
So that's the reason in yarn site.xml, this is purely related to yarn implementation, and yarn is basically Hadoop 2.x. Okay. So I will tell you, there is an application master is there, container is there, resource manager is there, node manager is there. Okay, so all these technologies come in yarn. Okay, Hadoop 2.x. Okay, so what architecture we see? Hadoop 1.x architecture we see. Read and write. So what is a Hadoop 2.x architecture? So in 2.x architecture, the standby name node will come, active passive name node. Okay, more than one name node will come in picture. Okay, so that is yarn site.xml. And two more files are there. One is a master and one is slave. So it is keeping all the information, like this master, a list of machines that each runs secondary name node. Like, and slave is containing all the slave information. So master means only one node will be master, right? Other are the slave. Okay. So anybody wants to know, right? Any Hadoop configuration wants to know how many master, how many slave. If it is yarn site.xml, then multiple master node will be there, right? Multiple name nodes, right? So those entries will come in this masters. All the slave entry will come in this slave file. Okay. So this configuration we need to set while we are installing the Hadoop. Okay. And you can see these files in your VM. Like there is a location where Hadoop is present. There you can see the file etc/Hadoop, and there is a conf folder is there, conf. Okay, /etc/Hadoop /conf. So that folder you will get these all files. There are so many other files are there, but these files are main configuration file. So Hadoop configuration completely depend on these files. It may be related to common configuration, it may be related to Hadoop SDFS configuration, or it may be related to MapReduce configuration or yarn configuration. Okay. So whenever you see Hive configuration, so Hive is having its Hive site.xml and Hive env.sh. The terminologies are same. Okay. When you see the scoop or UG, so UG-env.sh will be there. Okay, UG-site.xml will be there. Okay, so basically what technology is, whatever tool we are using in Hadoop, the configuration will be related to that tool will be in that configuration file. Okay, so configuration file is having the properties that is related to that particular tool, whether it will be a Hive, scoop, page, anything. Okay. So Hadoop is, the main Hadoop is having two components. This is a vanilla Hadoop having two components as DFS and MapReduce. But other than that, the ecosystem having the multiple components. Pig is there, Hive is there, Scoop is there, HBase is there. So they have the separate installation configuration. So when you install Hadoop means only this, you can run as DFS command and you can run MapReduce job. Only two things you can do. So while you are installing Hadoop, only two things you can do. As DFS site.xml means Hadoop commands, SDFS command you can run, or you can run the MapReduce job. But you can't run Hive with Hadoop installation. You have to do separate Hive installation. For Scoop installation, UG installation, right? But they are all in a single ecosystem. Okay. But whatever the VM I provided, everything is there already pre-installed. But all things are manually installed. So first thing what is installed? Hadoop is installed first. That will be bringing the SDFS and MapReduce. After that, somebody installed Pig, then installed Hive, then there is no any sequence is not there. But Hadoop is prerequisite for any other ecosystem tool. If I say Pig, Hive, Scoop, if anything you want to run on top of the Hadoop only, right? That's the reason you see in the picture in the Hadoop. So in ecosystem, you see in the base is SDFS and MapReduce, right? These are the two base. Okay. Main base is the SDFS, right? Because this is a storage part. Okay. So where your exactly data will be stored. Okay. Okay, just go through this one PPT, and this is critical. I am thinking tomorrow to do MapReduce theory and practical. Okay.
Okay.
So I think so far you can revise it. Any problem or like anything like
Yeah.
once?
Tomorrow I do practice and if I have any questions, I'll ask.
Yeah, actually questions now you once you preparing it, definitely question will come to you and you can ask those questions. And these are purely theoretical questions. And I'll do one thing. I'll share my previous recordings, right? I think that will give the more clarity, right? You can on one workshop folder is there. I will share that. Okay.
Okay. Okay. Yeah.
That workshop folder I will show you. This workshop folder. They will already having the pre-recordings. Okay. High recordings are there, and because I started previously directly high, because some people who already know the fundamental things. So MapReduce I didn't cover. I started high. So I will cover MapReduce, but after that you can see high sessions, Scoop sessions. Okay, I'll share this, and this one is having also commands. Okay.
Okay.
So I will share this complete folder. Okay. Yeah. Okay. Thank you. Yeah. Bye.
Yeah. Thank you.